Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Jest, Tifr, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 5th of optics, in which we are going to discuss CSIR net optics PYQs. Okay, so I'm going to start now, and also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help the students to crack their exams related to physical science. Okay, so I'll start now. The first PYQ from optics is this is these are CSIR net optics PYQs. Okay, a beam a beam of a beam of unpolarized light a beam of a beam of unpolarized light in a medium in a medium in a medium with dielectric constant with dielectric constant constant epsilon 1 is reflected is reflected reflected from a plane reflected from a interface plane interface place interface formed with another medium of dielectric constant of dielectric dielectric constant of dielectric constants epsilon 2 equal to 3 epsilon 1. Okay, the two media have the two media have identical magnetic identical identical magnetic magnetic permeability permeability if angle of incidence if angle of incidence is 60 degree then the reflected light reflected reflected light options are is plane polarized is plane polarized perpendicular to perpendicular to the plane of incidence the plane of incidence plane of incidence Okay, option B is is a plane polarized, is plane polarized, is plane polarized perpendicular to perpendicular perpendicular to my apology, it's parallel to, okay, plane polarized parallel to the plane of incidence, the plane of incidence plane of incident. Option C is circularly polarized, is circularly polarized, is circularly polarized, is circularly polarized. Okay, and option D is has same polarization, has has same polarization, has same polarization as the incident, as the incident light, as the incident light. Okay, so these are the options. The question is, a beam of unpolarized light is in a medium, okay, in a medium with dielectric constant epsilon 1, okay, is reflected from a plane of interface formed with another medium of the dielectric constant epsilon 2 equal to 3 epsilon 1, okay. The two media have identical magnetic permeability. If the angle of incidence is 60, then the reflected light is plane polarized perpendicular to plane of incidence, is plane polarized parallel to the plane of incident, and is circularly polarized or has same polarization as the incident light. Okay, this is the question. Very simple question, I'll show you. So this is a plane of interface. Okay, so this is the medium epsilon 1 and this is a medium epsilon 2, which is 3 epsilon 1, and this is the interface. Okay, interface of medium. So interface, the plane, okay, this is the plane interface formed with medium, with two medium, okay, and this is perpendicular, okay, these are straight line, guys, okay. So this is the light, this is the beam of unpolarized light, which makes a 60-degree angle. This is the angle of incidence, okay, with normal, okay, and here we'll see like this, okay, this one, this is a straight line, okay. So since we have given that we have given epsilon r, relative permeability is epsilon 2 upon epsilon 1. This is medium 1, this is medium 1, this is medium 2, okay, and epsilon 2 value, you know, that is 3 epsilon 1 upon epsilon 1, right? This will get cancelled, that is, so epsilon r value is 3, and it means the refractive index n is going to be root epsilon r, right? We know that is root 3. So this is the refractive index of the medium, okay. And now we know that Brewster angle, right? That is 10 IP, angle of polarization, is equal to, we know that is n, right? This we know, n or m, right? And so it means 10 IP is root 3. It means value of Brewster angle, that is IP, the angle of polarization, that is 10 inverse root 3, right? And this means this value is 60 degree. Now here you can see angle of incidence is 60 degree, I, right? And angle of angle of angle of polarization is 60 degree, right? So from here you can see angle of incidence equal to angle of polarization. So this means, this shows, because angle of incidence is equal to angle of polarization, right? It means the light is plane polarized, okay? Light is plane polarized, which is perpendicular to plane of incidence, okay? So this is the light. This is the light which is plane polarized and which is perpendicular to plane the plane of incidence, okay? This plane perpendicular to this plane, and if this is perpendicular, if the light which is plane polarized and perpendicular to plane of incidence, right? And then this is denoted by like this straight line, right? And this dot shows, right? This polarized light is perpendicular to the plane, right? So this means if angle of incidence equal to angle of polarization, so it means the option A is the correct, okay? Is plane. So the light is plane polarized perpendicular to the plane of incidence, okay? So this is the answer, guys. Option A. Very simple question, and it's the CSIR net physics PYQ of optics, okay? Next question, guys. Next question is question 2. Question 2 is, a screen has two slits. A screen has two slits, each of width w with their centers at a distance 2w apart, okay? 2w apart. Okay? It is illuminated by a monochromatic plane wave traveling along the x-axis, the intensity of the interference pattern the intensity of the interference pattern measured on a distant screen at an angle theta equal to n lambda upon omega, okay? to the axis, to the axis is. Okay, options are, option A is 0 for n equal to 1 comma 2 comma 3 so on. Option B is maximum for max for n equal to 1 2 3 so on. Okay, and option C is maximum for max for n equal to half comma 3 by 2 comma 5 by 2 so on, and option D is 0 for n equal to 0 only. Okay, 0 only. Okay, so this is the question. I'll read it for you. So this is a screen has two slit. We have a screen, two slit, each of width w. Okay, with their center at a distance 2 omega. Okay, with their centers at a distance to w. Okay, that is given. So the distance between the centers of slit is 2w. Okay, and if it is illuminated by monochromatic plane wave traveling along the x-axis, the intensity of the interference pattern measured on the distance screen at angle theta equal to n lambda upon omega to the axis is. Okay, so here it's a double slit experiment, guys. Okay, so Young's double slit experiment it is, right? So there are two slits, their distance the distance between them is given. Okay, and which is illuminated by monochromatic light plane wave. Okay, monochromatic plane wave traveling along x-axis. The intensity of the interference pattern you need to find out, guys. Okay, which I have already explained what is a double slit Young experiment. So you can check my optics class, right? So in first two lectures I have explained interference in detail. Okay, well, so it means I'll solve it now. Okay, so we have this one. Okay, so double slit experiment, it is a double slit experiment, guys, like this. Okay, so this is center, and this distance is w, 2w. Okay, and the width is w and width is w. Okay, and this is just briefly explain. Okay, and this is the screen. Okay, and at any point this there is a P, and here we need to find out the interference pattern. Okay, so this the distance between two centers is, this is 2w. Okay, and the width of slit is w. Okay, so this is the interference pattern we need to find out. Now we know here, right? We know that delta, that is path difference, is d sine theta, right? We know this is d sine theta. You can take theta like this, and if one light comes from here and one light comes from here, right? This is the path difference. This angle is theta, right? We know. So delta equal to d. I have explained in detail, guys. So you can check my optics class of interference. Okay. So this is delta equal to d sine theta, and so delta equal to d is the distance between the centers of the width of slit, right? The two centers of the two slits, right? So this is 2w is given, we have. Okay, 2w, and this is sine theta. Okay, this is, guys, w, not omega. Okay, this is w. So this is 2w sine theta. Okay, so from here and for very small angle, so because angle is very small, right? So for very small angle, sine theta is almost equal to Sin theta is almost equal to theta. Okay, so it means theta, so delta is going to be 2 omega theta. Okay, now this one, or we can write delta equal to 2 omega theta value is given, guys, we have been given. Okay, so pattern measured, so we need to find out intensity, the intensity of interference pattern measured on the distant screen at angle theta equal to this axis. Okay, so this is going to be 2 omega, and theta value is given, right? This is n lambda upon omega. My apologies, it's w. W will get cancelled. Okay, so delta is going to be 2n lambda. Okay, delta is going to be 2n lambda. So it means this is delta equal to 2n lambda, right? This means this is this means and for value of n equal to 1, 2, 3, right? So on. So it means intensity. Very good question. Intensity is maximum, because we know, right? For intensity is maximum. We know for that is for maximum for constructive interference, or for maximum to get brightness of fringes, or for constructive interference, delta equal to n lambda, right? So this is in this form, right? Delta equal to 2 n lambda, where n is 1, 2, 3, so on, right? Uh, n is 1, 2, 3, so on. Okay, so simple. So it means the intensity is maximum, right? At that point we'll get bright fringes, means intensity is maximum for n equal to 1, 2, 3, so on. So which option is matching, guys? Option maximum 1, 2, 3. Option B is matching, guys. Okay, maximum for n equal to 1, 2, 3. Okay, so because this is in this form, right? 2n plus lambda, or we can write n plus lambda, right? So it's this part difference shows for maximum intensity. So intensity is maximum for n equal to 1, 2, 3, so on. Okay, this one, guys. Next question, question number 3rd. Question number 3rd is electric field of electric field of an electromagnetic wave of an electro of an electromagnetic wave electric field of an electromagnetic wave is E is given. Okay, let me just check the voice, guide. Am I audible or not first? Okay, because many times I face this difficulty, so I just want to check. Question number 3rd is, yeah, I'm audible, so I'll proceed further. Okay, so electric field of an electromagnetic wave is E given. Okay, that is given, which is a function of Z and T, function of Z and T equal to E naught cos kz plus omega. Okay, that is I cap, plus 2 E naught sin kz plus omega j cap. Okay, where W and K are omega and K are positive constants, K are positive constants this represents option A, a linearly polarized wave, a linearly polarized wave traveling in the positive z direction, in the positive z direction. Option B is circularly polarized wave, uh, circularly polarized wave traveling in the negative z direction. Option C is elliptically polarized wave. Elliptically polarized wave traveling in the positive z direction. Traveling in the positive z direction. Positive z direction. Option D is an unpolarized wave, an unpolarized wave traveling in the positive z direction, in the positive z direction. Okay, so this is the question. So electric field of an electromagnetic wave is given, okay, where omega and k are positive constants. So this represents, okay, so it is a linearly polarized wave traveling in positive z direction, or it's a circularly polarized wave traveling in minus z direction, or this is a elliptically polarized wave traveling in positive z direction, or it is a unpolarized wave traveling in the positive z direction. That we need to find out. Okay, very good question. I have solved many questions of this. Okay, so here we have been given in polarization. I have solved many questions, and I have told you the trick as well, right? There's a trick of checking whether it is circularly polarized, plane polarized, or elliptically polarized. Everything I have taught in my uh, polarize in my lecture, that is polarization of light, right? So you can check my lecture of optics. Okay, so here this E, that is electric field, is which is function of Z and T, that is equal to E naught cos the given, right, kz plus omega t I cap plus 2 E naught sine kz plus omega t, right? So this is given. So from here, right, we have been given kz plus omega t. We can say kz plus omega t equal to 0. So from here, value of z is going to be minus omega t upon k. So if this is the, then this means that shows the direction of wave is negative z direction. Okay, note it, very important point, guys. If kz plus omega is given, then it means this is in negative z direction. Similarly, if kz minus omega t is given, okay, kz minus omega t is given, it means the value of z is going to be omega t upon k. This implies the direction of wave is positive z direction. You need to note down, guys. Okay, in any question, if you see cos kz plus omega t or e to the power kz plus omega t, it means negative direction. Okay, if kz minus omega t you see, then it means it's positive direction. Okay, I hope you understood it, guys. Very important point, you need to note down these points. Okay, so now we have got the direction, right? From here we can easily find out it is circularly polarized in the negative z direction, right? Because this we know. Okay, but I will solve it completely. So here you can see this because E is in the form, this, guys, E is in the form E naught cos kz plus omega t I cap plus 2 E naught sin kz plus omega t. Okay, so it means the value of that phase difference is going to be pi by 2. If because since cos and sin are there, cos and sin are there. Okay, cos theta and sin theta are there. If they are, if these are present, it means the theta value is going to be pi by 2. My apology, it's a pi value is going to be pi by 2. Okay, and we can see also we can see E naught 1 not equal to E naught 2, right? Here you can see yeah, so E1 naught, this is E1 and this is 2 E naught. This is E naught, it is 2 E naught, right? So E1 not E1 E naught 1 not equal to E naught 2, right? So this condition is if theta is in the form of n pi by 2, we know that trick I have already explained in polarization of light, guys. Please check it. So if theta equal to in the form of n pi by 2, right? So it means that is circularly that is elliptically polarized, guys. Okay, that is elliptically polarized. Yeah, if right, and if E naught okay, so if pi value, right, the phi value is n pi by 2 and E naught 1 not equal to E naught 2, in that case it is elliptically polarized. If the value theta is pi by 2 but E naught 1 equal to E naught 2, then it is circularly polarized, right? Okay, so here we can see it is pi by 2 and in pi by 2, right? This is we can see in n pi by 2 form, right? So it means wave is elliptically polarized, elliptically polarized, and in negative in negative z direction. So which option is matching, guys? It is not circularly polarized, guys. Okay, so which option is matching? Option D is matching, guys. Sorry, option C, elliptically polarized and wave is traveling in. Okay, so there is a mistake we have done. This is elliptically polarized in negative z direction, guys. I have written wrong. Okay, so this is polarized in elliptically polarized wave traveling in negative z direction. Okay, so option C is the correct, guys. Okay, option C. I hope you understood. It's okay, guys. I hope you have understood it. Okay, well, okay, guys. So I'm going to stop here, and in next class I'm going to solve optics gate PYQs. Okay, and then optics just PYQ, and then the optics course is going to be completed. Okay, guys. So I just request the people or students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, guys, bye now.